Okay, section 6.3, example 1, page 310. We are looking at proving the identities. So that was the part that I said was the best part, where you try to make one side and prove that it was the same on the other side. Okay, so the first question says, verify that 1 minus sine squared x is equal to sine x cos x cot x for the same values of x. Determine the non-permissible values for x. Works in degrees. Okay, so what are the non-permissible values? Those are usually when you don't want something in the bottom because it's going to make it undefined. Okay, so do any of those have a bottom? One of them does. Which one? Cotangent. Okay, so cotangent is the same as what? Cotangent is the same as sine over cos? Cos over sine? So what we need to worry about is where sine is 0. So on our unit circle, sine is 0 is where? Pi over, no, it's at pi or 180 degrees, right? So we could say 180 n or we could say pi n. I just chose degrees because we were working in degrees here. Okay, so it says verify that 1 minus sine squared x is equal to sine, cos, and cot. Okay, so we need to verify this first. So let's just choose, and we're saying for, it says for the same value of x. So we can just choose a random value for x. I always like 30 degrees just because sine 30 is a half or 0.5. It sometimes makes for easier decimals. So this is where we always did a left side and a right side. Okay, so if we put 30 degrees in this question, on this side we have 1 minus sine squared, and we'll put 30 degrees in there. Okay, so remember, if we looked on our unit circle, sine 30 is a half. If we did our special triangles, opposite over hypotenuse, we'd get a half. Okay, so this one, instead of writing sine 30, we'll put the value of what sine 30 is, and make sure we put the squared because sine was squared. Okay, so when we square a half, it's 1 times 1 is 1, and 2 times 2 is 4. And we have 1 subtract a quarter. So 1 subtract a quarter, so that is, if you want to make the 1 into a matching denominator, 4 quarters minus 1 quarter is 3 quarters. Okay, so this side equals 3 quarters. So in order for this to be true, the other side has to work out to 3 quarters when we work through it. Okay, so if we put the values in, so what is sine, remember, at 30? So we're going to go whatever sine 30 and cos 30 and then cot 30. Okay, so sine 30 we said was a half, right? What is cos 30? And if we want, I can put the special triangle. So say this was 30 degrees. So this is 1, this is root 3, and that's 2. Okay, so if we wanted to see what cos 30 is, you go from the 30 degrees and you go adjacent over hypotenuse. So it's root 3 over 2. Or you could look on the unit circle and see what cos 30 was, and it would be root 3 over 2. Okay, and then we can find cot 30 by just going what tan 30 is and finding the reciprocal. So tan 30 degrees, we'd start from here, and tan is opposite over adjacent, which is 1 over root 3. So cotangent has to be root 3 over 1. Okay, so now we have the exact values for all of those guys. And we just multiply because they're all multiplying together. So 1 times root 3 times root 3. Yeah, it's the root of 9, which is just 3. And then 2 times 2 is 4 times 1 is 4. So we verified that both sides equal 3/4. So that means that this side should simplify to that one once we figure it out. Okay, so now comes the fun part of this. And it's prove that 1 minus sine squared x is equal to sine x, cos x, and cot x. Okay, so in order to prove that, all we have to do is get both sides to look exactly the same. And if we get sine equals sine or cos squared equals cos squared, then we know that we've come out with the right answer. Okay, so we're just going to try to manipulate these until they are exactly what each other are on each side. Okay, so what can we replace 1 minus sine squared with? What's that? I should get my things out. Okay, whenever I see this sine squared one, and I don't see a 2, if I saw a big 2 with it, I always would automatically think double angle identities. Okay, but this one does not have a big 2. So the only other time you see the squareds is the Pythagorean identity. So remember, this one, cos squared plus sine squared equals 1 on our identity sheets. This can be manipulated, right? So if I subtract cos squared over, I get sine squared is equal to 1 minus cos squared. Okay, or I could subtract the sine squared over. So say this is my original equation again. If I subtracted the sine squared over, I get cos squared is equal to 1 minus sine squared. Okay, so I could subtract the cos over, or I could have subtracted the sine, and that is still the same equation, it's just I manipulated it a little bit. Okay, so do you see this one? 1 minus sine squared is equal to cos squared. We have a 1 minus sine squared here. So instead of having 1 minus sine squared, what could we put? We could put cos squared. Okay, so we simplified that side. And if we can get this side here to equal cos squared, then we've proved it. So there's not really a whole lot we can do with sine x. Okay, we could probably switch them to cosecant, but that doesn't really get us anywhere. Okay, who can we change out of these guys? The cotangent. Because what is he? He is cos over sine, right? So keep in mind, these guys are all multiplying together because there's no sine in between. So instead of cotangent, I'm going to write it as cos over sine because that's the same thing. Okay. Now we have all these guys multiplying together. So this can cross off with this. Okay, so the sine can cross off with the sine. And we're left with a cos times a cos, which is what? Cos squared. And now we have cos squared x equals cos squared x, so we proved the equation. Okay, so example 2 on page 311, it's asking us to prove that tan x is equal to 1 over cos 2x over sine 2x. Okay, so this tan x side is pretty simple right now. There's not a whole lot you can do to it. So the key when you have one side that's really simple and one that's confusing, switch the side that's confusing until it looks like the one that's simple. Okay, so we're not going to do anything here right now, but what we're going to do is we're going to try to get this to be tan x. Okay, so we need to look at our identity sheet, and what could we replace 1 minus cos 2x with? Or can we replace cos 2x with something? or cos 2a, it has 3 options usually, right? Does it not? Okay, so maybe let's look at the bottom first, because cos always has so many options, you never know which one do you pick. Okay, so maybe once we see the bottom, we'll be able to see which one is going to work the best for the top. Okay, so can we switch sine 2x to anything? Okay, so it's 2 sine, and I'm just going to put x's because they're using x's here. 2 sine x cos x, right? Because this one's the double angle identity for sine. Okay, so we need to get to figure out what we can replace cos 2x with. Okay, and this is where people hate trial and error, but this is where it comes into play. Okay, so in my head, when I'm thinking through these, I think, what is tan? Tan is cos over sine, right? So our mission is we want to have a cos in the top and a sine in the bottom. Okay, so we're not worried about getting rid of this sign here because he is what tan can be, right? Oh, is it? Did I say it backwards? Sine over cos? Oh, okay. So here we go. Don't go with that theory. Since tan is sine over cos, we want to try to get rid of the sine in the bottom because we need a cos. Okay, so which one of those cos 2x ones has just sine in it? Is there any? Okay, 1 minus 2 sine squared x. And remember, we still have this 1 minus in front, right? Okay, so we replace the cos 2x with this guy right here, okay? In the theory that we don't want this sine x in the bottom because tan is sine over cos, okay? So this negative goes into both of these pieces. So we would have 1 minus 1 plus 2 sine squared x, and we still have our bottom 2 sine x cos x. Okay, so 1 minus 1 is just 0. So really all we have is a 2 sine squared in the top. Okay, can we cross off the 2's also? 2 in the top, 2 in the bottom. Okay, so now we have it down to sine squared over sine x cos x. And if you think about sine squared is just sine times sine, right? So you should be able to cross one of those guys with one of those guys. And all we have left is sine over cos. And what is sine over cos? It's tan.